So in this video, I am going to explain about organic compounds containing nitrogen. That means amines, diazonium compounds, cyanates and isocyanates. Worksheet questions. We will discuss one by one. So first question, matching. So amide. Option A, amide. Amide will be converted to amine in Hoffman bromide reaction. Hoffman bromide reaction. Next, option B. Option B, nitrile. Nitrile will be converted to primary amine by reducing with lithium aluminum hydride. LiAlH4 reducing agent. Next, C. So C6H5 SO2Cl. Benzene sulfonyl chloride. It is used in Hinsberg test. Distinguishing of primary, secondary and tertiary amines. And D, primary amine. So primary amine will give carbylamine test or isocyanate test. Carbylamine test or isocyanate test. So that means amide. Amide gives Hoffman bromide. That means for A, 3. For B, nitrile, 4. Next, for C6H5SO2Cl, that means benzene sulfonyl chloride, Hinsberg reagent, so which is 2. And for D, primary amines, carbylamine test, 1. So therefore, 3, 4, 2, 1. It is present in option B. Next question. Among the following set of reactions, the most suitable method for preparation of secondary amines. So simple. Here I am taking CH, CH3, CH3, CH2, NH2, which is primary amine, plus take benzaldehyde. Benzaldehyde can be written as C double bond OH on heating. So here removal of water molecules minus H2O, it will form CH, CH3, CH3, CH2, N double bond CH and the C6H5, which is benzene. So this will be known as imine, which is intermediate compound. So this on reduction with H2 in the presence of Pt, catalytical reduction, it will form CH3, CH, CH3. So here remove one bond and add hydrogen and hydrogen here. We will get CH2 right here. Next NH, CH2 and the benzene ring. So this is the compound here NH. So NH is secondary amine. So this one benzaldehyde. So here reaction between primary amine and the carbonyl compounds, that is benzaldehyde. First it gives imine, intermediate compound, which on reduction gives NH containing compound, that means secondary amine. So therefore option C. Next, the starting material that produces pentanamine by half-bond bromamide reaction. So pentanamide means 5 carbons must be there. So we should take 6 carbon containing compound, that means CH3, CH2, 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 CH 5 carbons, and the last one must be CONH2. So this one amide functional group. So total 1, 2, 3, 4, 5, 6, 6 carbons. Hexanamide. Hexanamide. So which one reaction with NaOH and Br2. That means Br2 in the presence of alkali. So here remove just CO. It gives CH3, CH2, CH2, CH2 and CH2, NH2. 1, 2, 3, 4, 5. Pentanamine, which is given compound. From hexanamide, we will get pentanamine, which is amine. So Hoffman bromamide reaction is nothing but, so here this compound CONH2, the acid amide with Br2 alkali. Alkali means NaOH or KOH can be used. It will be converted to NH2, which is amine. This is Hoffman bromamide reaction or Hoffman degradation reaction. See here option D. Hexanamide will give pentanamine. Here CO will be removed in the form of CO2 in mechanism. Next. The correct order of basic strength of following amines is. In first option, this is alkyl amine, which is more basic than NH3. So when compared to ammonia, alkyl amines are more basic due to more donation of lone pair on nitrogen. Next, after that, pyridine, here this lone pair will be free lone pair, therefore it can donate lone pair easily. Next, last one, here there is conjugation between lone pair of nitrogen and pi bond. So due to conjugation, basic strength decreases, that is delocalization. So delocalization of lone pair of nitrogen. So due to delocalization, basic strength decreases. Next here sp3 carbon. Here also sp3 carbon. So here sp2 carbon. So when compared to sp2 carbon, sp3 carbon is more basic. That means sp3 nitrogen is more basic. sp3 nitrogen, sp3 nitrogen, sp2, and in last example there is delocalization of lone pair of nitrogen. So when compared to sp2, sp3 nitrogen is more basic. Less electron negative nitrogen, therefore it can donate electron pair easily. So this will be the order. So this is first example. Next this is third example. Next second example and fourth example. If nitrogen is directly attached to benzene ring, delocalization of lone pair takes place, then basic nature decreases. So sp3 nitrogen is more basic than sp2 nitrogen. Remember that point. So option D. Next. Identify X in the following reaction. So first it is given NH2 and here CH3. So first reaction NaNO2 plus HCl. So 0 to 5 degrees centigrade, very low temperature. So first it gives diazonium compound N2 plus and the Cl minus, diazotization. So after that fluoroboric acid. So substitution of fluorine, or we can write like this, N triple bond N plus and BF4 minus. So diazonium fluoroborate. Next, which one reaction with NaNO2 gives here NO2 and CH3. So this is required compound, which is X. Nitrotoluene. Last compound is para-nitrotoluene, which is option D. Very, very important reaction. First diazotization, next diazonium fluoroborate, intermediate compound, which on treatment with NaNO2 gives nitro substituted compound. Next, which of the following compounds undergo Hoffman degradation reaction or bromide reaction? So here this structure must be there. Amide with Br2 plus alkali, it gives NH2 amide. This is Hoffman degradation or Hoffman bromide reaction. So here in given set of compounds CH3 CONH2, which is acetamide with Br2, say NaOH, or you can take KOH. See a removal of CO. It gives CH3 NH2 methyl amide. This is Hoffman bromide reaction. Amide will be converted to amine in the presence of bromine and alkali. So this will be known as primary amide. So primary amide undergoes Hoffman degradation reaction or Hoffman bromide reaction. Hoffman degradation or Hoffman bromide reaction. Very, very important. Therefore, option C, primary amide. If it is NH, secondary amide. If it is N, tertiary amide. Only primary amide undergoes Hoffman degradation reaction. Next. So identify X, Y, Z in the following sequence. So first acetic acid is given, CH3COOH. First it reacts with NH3, which is base, to form salt. CH3 COO minus NH4 plus ammonium acetate. So which on heating gives CH3CONH2 with release of H2O. H2O will be removed. So this is acetamide. Acetamide. Next. So which on reaction with C6H5SO2Cl benzene sulfonyl chloride in the presence of pyridine. So pyridine is base that removes HCl. So here minus HCl gives CH3CONH. So here H and Cl will be removed. NHSO2 and the phenyl. So this will be the compound. Removal of HCl. So pyridine basic and removes HCl easily. So CH3CONH SO2 C6H5. So option B. So which is major compound? Say this is X. Otherwise I will write like this. So first water is removed. Therefore X is say water. Next say Y is HCl and last Z is final compound. So first I am taking final compound as X. Say this is X. X is CH3CONH SO2 C6H5. Next say Y is H2O and Z is HCl. So option B. In any way you can take X, Y, Z. So main compound is X. Remaining Y and Z are byproducts H2O and HCl. Next. So cyclohexylamine and aniline can be distinguished by cyclohexylamine. This is cyclohexylamine. So which is primary amine. Next aniline. Aniline. This is also primary amine. Can be distinguished by. So this is aliphatic or we can say alicyclic. And this will be aromatic amine. So these two are distinguished with azo dye test, which is very important. Azo dye test. Now let test here. First I am taking aniline, which is aromatic amine. Reaction with NaNO2 HCl 0 to 5 degrees centigrade. It will be converted to benzene disonium chloride N2 plus and Cl minus. You will write like this. N2 plus and Cl minus benzene disonium chloride. So which on reaction with beta naphthol that gives final compound naphthalene derivative Here OH and here diazonium compound will be substituted. So this is azo dye, which is a red colored dye. So this linkage will be azo linkage or diazo linkage. This is conformation test for aromatic primary amines. Aniline. This. And this one benzene diazonium chloride. So very important. So azo dye test is special test for aromatic primary amines. So here D. Aliphatic and aromatic primary amines can be distinguished by azo dye test. Next. Identify Z in the following reaction. Simple reaction. First NH2 is given, which is aniline. First diazotization. NaNO2 plus HCl 0 to 5 degrees centigrade. First it gives benzene diazonium chloride. Benzene diazonium chloride. Next, which on reaction with Ki under heat, it gives iodobenzene. So best method to prepare haloarenes, iodobenzene. So option C, iodobenzene. Next, choose the correct order of basicity of the following. Basicity. So first one diethyl amine is given. Diethyl. Next ethyl. Next ammonia. Next D aniline. So we know when compared to aromatic, aliphatic amines greater than aromatic amines towards basic nature. Remember this, basic nature. So aromatic amine is aniline here, last compound. A, B, C are aliphatic. Next, in case of ethyl amines, the basic order is secondary, tertiary, primary and NH3. Remember this order, basic nature. In case of ethyl amine, if ethyl group is substituted on nitrogen. So here first one secondary, that is A. After that B, ethyl, which is primary. So this is secondary and B is primary. Tertiary is not given here. Next C, which is ammonia, and last aromatic amine. Aromatic means D. Aromatic amines are least basic due to delocalization. Therefore, A, B, C, D. Option B. Aromatic amines are less basic due to delocalization. Delocalization. Delocalization of lone pair of nitrogen. So due to delocalization, donation capacity decreases. Next. So here option A, not option A, option B. A, B, C, D. Okay, next. Reagent P used for the conversion. Reagent P. So which is given in this way also we can write. This is amide or cyclopentyl carboxamide, which is simply amide. Amide functional group is present. Amide. So which are reaction with Br2 and NaOH, which is Hoffman bromamide reaction. Hoffman bromamide reaction. It gives NH2. Here CO will be removed in the form of CO2. So cyclopentyl amine. So which is simply amine. So amide will be converted to amine under the influence of Br2 and alkali. Hoffman bromamide or Hoffman degradation reaction. Therefore option C. Reagent is Br2 and alkali. Next. Identify major product of the following reaction. This is also simple. CONH2, which is benjamide. Benjamide with Br2 plus NaOH. Hoffman bromamide reaction. Here CO will be eliminated and it gives NH2, which is aniline. That means here amide will be converted to amine. Hoffman bromamide. So very important. So option D, aniline will be formed. Next. What is P in the reaction given below? P. We should identify P. So here I am taking ethane nitrile. Nitrile means cyanide. It means two carbons, two carbon atoms. Ethane nitrile. So first on the reaction with CH3MgBr. So remove like this. That means dissociate like this. A delta minus and a delta plus. So CH3 attacks this electron deficient carbon and electron pair will be shifted towards nitrogen. It gives intermediate compound CH3 and here CH3 double bond N MgX. So which is intermediate compound which on hydrolysis it can form. Hydrolysis can be done like this. H2 OH2 and here H OH. So it gives CH3 COCH3 plus NH3 plus Mg X and OH, magnesium divalent. Therefore, halogen and hydroxy groups are attached. Next, I am taking this as P. This gives R. Next, which are reaction with NaOH and delta, which is aldol condensation. Aldol condensation means you must take 2 moles. 2 moles we can write like this: CH3, COCH3, and the second mole can be written like this. Remove here alpha, 2 alpha hydrogen atoms. It gives final compound CH3, CCH3, double bond CH, COCH3. So 1, 2, 3, 4, 5. So this becomes substitution. So therefore IUPAC name will be 4-methyl 4-methyl pent, root word is pent, 3 in and 2 on. So this is IUPAC name. So this is given compound. So first time I have taken here P. P as ethane nitrile, which on reaction with Grignard's reagent followed by hydrolysis gives ketone, which on aldol condensation followed by heating gives alpha beta unsaturated ketone. So this will be alpha beta unsaturated ketone. And IUPAC name is 4-methyl pent 3 in 2. So therefore option C. Initial compound is ethane nitrile, or we can say methyl cyanide. Common name. Methyl cyanide. Next. The order of boiling points of following compounds is order of boiling points. So here first one, tertiary amine CH3 thrice N, tertiary amine. Next CH3, CH2, CH2, NH2, which is primary amine. Third one CH3, CH2, NH, CH3, which is secondary amine. So we know as the branching increases, boiling point decreases. As the branching increases, boiling point decreases. Or we can say, so second primary amine is NH2. It can form hydrogen bonding very easily when compared to remaining. As the branching increases, boiling point decreases. Remember this point. That means tertiary amine is more branched. More branched means crowding will be there. Crowding. So therefore, order of boiling points. First, second option. Next, third option. Next, first. So lowest boiling is for first option, tertiary. So more branching. So straight chain amines will be having more boiling point when compared to branched. So moreover, primary amine can form hydrogen bonds very easily. Hydrogen bonding is very easy. You can form hydrogen bonds more quickly when compared to remaining. So after that, secondary amine, next tertiary amine. So therefore option D. Next, this is also simple question. Identify X, Y, Z used in conversion of 3-methyl-aniline to 3-nitrotoluene. So 3-methyl-aniline, aniline NH2, 3-methyl, 1, 2, 3, to 3-nitrotoluene. Here 1, 2, 3. So what are the reagents required? So here I am converting like this. So first NaNO2 HCl 0 to 5 degrees. First it gives diazonium compound. Here CH3 N2 plus and Cl minus diazonium compound. This is first compound. Next. After that, say HbF4. So HbF4, it will be converted to diazonium fluoroborate BF4 minus, which on treatment with NaNO2 in the presence of Cu followed by heating gives NO2. So NO2 will be substituted in place of nitrogen. This is the conversion. That means first reagent NaNO2 HCl. So 0 to 5 degrees centigrade. Next HbF4. Next NaNO2. Therefore option A. Very, very important. Next. Acidic acid on heating with NH3 forms A. A reacts with lithium aluminum hydride followed by hydrolysis gives B. When B is heated with chloroform in KOH medium gives C. What are B and C respectively? First acetic acid CH3 COOH that reacts with NH3 followed by heating gives acid amide. Acid amide, which is A. A reacts with lithium aluminum hydride gives, that is followed by hydrolysis also. H2O, remove O like this, add H2 and H2 here. It will be converted to CH3 CH2 NH2, so which is primary amine, and it is B. So B, when heated with chloroform CHCl3 in KOH medium gives, on heating, it gives CH3 CH2 NC isocyanide. So which is C. Isocyanide test or carbylamine test. Here first compound we have to identify B and C only. B is CH3 CH2 NH2 propanamine, and last compound C is CH3 CH2 NC isocyanide, which has foul smell, very bad smell due to the formation of isocyanide. Therefore option B. All are important reactions. Next. Here, what are A and B in the following sequence? Propionitrile, that means CH3, CH2, CN, propionitrile. So plus compound A, they are asking A. Here A can be C6H5MgBr, phenyl magnesium bromide, which is Grignard's reagent. So you can dissociate like this, here minus and here plus. Here also delta minus and here delta plus. Shiftingly like this. So first it gives CH3, CH2. So I will write here minus attacks here. Nucleophilic addition. CH3, CH2. Next C. For here C6H5. Double bond N, MgBr. So which one hydrolysis gives? Here hydrolysis means remove like this. Here O and H2. Again here H and OH. So final compound will be CH3, CH2, CO, C6H5 ketone. Plus byproduct is NH3 and Mg, Br and OH. So these are final compounds. So here they are asking what is A. A means C6H5MgBr, Grignard's reagent, which is A. This is compound A. Next intermediate compound is B. And the last compound is C. This is C. Very, very important. First nucleophilic addition followed by hydrolysis. H2O, H plus. H3O plus means acidic hydrolysis. Next. So what are X and Y in the following reactions? So X is test for aniline. So NH2, bromine water. Br2 aqueous solution means tribromo derivative NH2. Aromatic electrophilic substitution. This is tribromo aniline, which is white PPT. This can be used as test for aniline. Next, second reaction. I am writing here second reaction. First aniline. Next acetic anhydride. CH3CO twice O. Acetic anhydride means acetylation takes place. Acetylation. That means NH COCH3. Acetanilide. Acetanilide. So which one reaction with Br2 in the presence of acid, electrophilic substitution at only para position due to bulky group at ortho. NHCOCH3 and here Br. This is major compound. Now check the options. Option A. First white PPT test for aniline. Next first acetylation, second reaction first acetylation that gives acetanilide. Next bromine substitution, electrophilic substitution only at para position. Para isomer is measured due to bulky group at ortho. Next. Yellow dye can be prepared by coupling reaction of benzene diazonium chloride with some X. Identify X. So here benzene diazonium chloride and aniline. First I am taking aniline plus benzene diazonium chloride, N2 plus Cl minus. In acidic medium, so here NH2 is electron donating group, which is ortho and para directing group. Ortho and para directing group. And here benzene diazonium acts as electrophile. That electrophile will be substituted at para position due to bulky nature. Therefore, it gives compound will be like this: NH2 at para position, N double bond N. This compound will be formed. Name is para amino azobenzene, which is yellow dye or aniline yellow dye. Aniline yellow dye. So therefore option A. Aniline reacts with benzene diazonium chloride to form aniline yellow dye. So this is best example for aromatic electrophilic substitution. Here benzene diazonium acts as electrophile. So this will be electrophile. This electrophile will be substituted at para position of aniline due to bulky nature. For option A. Next. So out of the following amides, which will not undergo Hoffman bromamide reaction? Next. Already I have given this equation. CONH2. This is primary amide. Will be converted to, in the presence of alkali, will be converted to primary amine. So this structure must be present. This structure CONH2 must be present. But here in option A, CH3CONH, CONHCH3 is given. This is secondary amide. Secondary amide will not undergo Hoffman bromamide reaction. Check remaining are CONH2 primary amide, CONH2 primary amide, CONH2 primary amide. But here NHCH3 means secondary amide. That will not undergo. Will not give Hoffman bromamide reaction. So very important. Only primary amides will give Hoffman bromamide reaction. Remember this, NH2 must be there here, NH2. NH2. Here NHCH3 is present, that is not possible. Therefore option A. For option A, Hoffman bromamide reaction not possible. Next. In the set of reactions, 2-bromopropane with alcoholic AgCN gives X, X with LiLH4 gives Y, IUPAC name of Y. So first bromopropane, 2-bromopropane, 2-bromopropane with alcoholic AgCN, silver cyanide, gives CH3, CH, CH3 with AgCN, it gives isocyanide like this, isocyanide. Isocyanide, which is X. Next, which on reaction with lithium aluminum hydride. So here unequal breaking, dissociate like this, add here one H and here H3. Dissociate only two bonds. It gives CH3, CH, CH3, NH, CH3. So which is secondary amine. NH means secondary amine. Next, IUPAC name of this compound is, so on nitrogen, here on nitrogen methyl group is present, therefore N-methyl, writing name here, N-methyl propane 2-amine, which is very important. So this will be longest possible chain. This will be longest possible chain. 1, 2, 3. On second position, amine group is present. Propanamine, propane 2-amine. On nitrogen, 1 CH3 substitution is present. So here this CH3 becomes substitution. So first name is propane 2-amine. So due to the presence of methyl and nitrogen, it becomes N-methyl propane 2-amine. That is IUPAC name. Therefore, option B. So very important. Next. An organic compound A on reduction gives compound B, which on reaction with trichloromethane, which is chloroform, and caustic soda forms C. The compound C on catalytical reduction gives N-methyl benzenamine. Compound A is. Here organic compound I am taking NO2. Nitrobenzene. On reduction, say suppose H2Ni reduction, catalytical reduction. First it gives NH2 aniline. This is compound A. On reduction gives B, which is aniline. So which on reaction with trichloromethane, that is chloroform, and KOH gives carbylamine reaction. So this gives isocyanide, which is C, isocyanide test. Next, which on catalytical reduction, LaLH4. So dissociate only two bonds and add here H and here H3. So final compound will be NH CH3. So name of this compound, So on N-methyl substitution is present. N-methyl benzenamine. So benzenamine is IUPAC name for aniline. So here identify A. So what is a nitrobenzene? Therefore option A. So nitrobenzene on reduction gives first aniline. This will be aniline or benzenamine. Benzene amine is IUPAC name for aniline. Which on treatment with chloroform KOH gives isocyanate. Isocyanate test. Next on reduction gives N-methyl benzenamine, which is secondary amine. NH means second. Option A. Next. The correct order of increasing basic nature for the given compounds. So for methylamines order is secondary, primary, tertiary and ammonia. This will be the order. Basic nature. In aqueous solution. Very important. So here secondary is CH3 twice NH. CH3 twice NH. This is secondary amine. After that primary is there CH3NH2, which is primary. After that NH3 ammonia. This is the increasing order. Increasing order of basic strength. Very important. Ethylamines, methylamines, both are important in aqueous solution. Secondary, primary, tertiary is not given here. Next, ammonia. Therefore, option D. Next. Which of the following is more basic than aniline? So here aniline. Next, diphenylaniline. This is option A. Option A. This is aniline. So diphenylaniline means like this. Or diphenylamine. So this one option A. Next, triphenylamine. Triphenyl. This is option B. Next, para-nitroaniline. The nitro group is electron with drying group. At last, benzylamine. CH2NH2. This is option D. See here in A, B, C, nitrogen atom is directly attached to benzene. If nitrogen atom is directly attached to benzene ring, comma, basic strength decreases. Very important. Due to delocalization. If nitrogen atom is directly attached to benzene ring, basic strength decreases due to delocalization. So delocalization of lone pair of nitrogen. Remember this point. Very important. So in last option D, nitrogen atom is not directly attached to benzene. Therefore, it can donate electrons easily. Therefore, most basic is benzylamine. Very, very important compound. Benzylamine. If nitrogen atom is directly attached to benzene ring, basic strength decreases. Therefore, in D option, it is not directly attached. Next. Which of the following is least soluble in water at 298 Kelvin? That means room temperature. See here. Option A, option B, option C can form hydrogen bonds with water. But here, option D, C6H5 allyl structure is hydrophobic. Hydrophobic part. So therefore, this hydrophobic part prevents from hydrogen bonding. So if hydrophobic part is present, hydrogen bonding is not possible. Therefore, this compound will be least soluble. If there is formation of hydrogen bonds with water, that compound will be more soluble. Here hydrophobic part, phenyl group is hydrophobic part. This prevents the compound for the formation of hydrogen bonding. Therefore, least soluble. Therefore, option D. In remaining cases, hydrogen bonding is possible. Option A, B, C, hydrogen bonding possible. I will write like this, least soluble due to hydrophobic part. Next. So which of the following has lowest boiling point? So lowest boiling point. Check here. Either functional group. So almost non-polar compounds. So non-polar compounds cannot form hydrogen bonds. So due to intermolecular hydrogen bonding, if intermolecular hydrogen bonding increases, boiling point increases. Here there is no formation of hydrogen bond in case of ether. Almost non-polar. Therefore, it will be having lowest boiling point. Lowest boiling point. In remaining cases, NH, polar part, that can form hydrogen bond. Next, COOH, it can form hydrogen bond. Next, OH, polar, it can form hydrogen bond. This is non-polar and there will be no hydrogen bonding. No intermolecular hydrogen bonding, least boiling point. So, option B, ethers. Next, Hinsberg reagent is Hinsberg reagent. Benzene sulfonyl chloride. The Hinsberg reagent. SO2Cl. The Hinsberg reagent. It can be used to distinguish primary, secondary, tertiary amines. For option A. This is also previous question. Next. So the method by which aniline cannot be prepared is, if you take option D, potassium salt of phthalimide. Phthalimide will be like this, potassium salt N minus and K plus. This is potassium phthalimide. Chlorobenzene. Chlorobenzene. Here there is conjugation between lone pairs of chlorine and pi bonds of benzene. Here there is delocalization. So due to this, structure will become like this. So there will be double bond formation between chlorine and carbon. This gives structure like this. Here Cl plus and C minus. Double bond character. So therefore displacement not possible. Not possible. That is simply no reaction. So due to double bond character, here double bond character. It is not easy to break double bond. Therefore displacement is not possible. Therefore phthalimide ion cannot attack carbon atom containing, that means carrying chlorine. Displacement is not possible. By this method, primary amines cannot be prepared. Aromatic primary amines cannot be prepared by Gabriel phthalimide synthesis. This is Gabriel phthalimide synthesis. This is best to prepare only aliphatic primary amines. Best for only aliphatic primary amines. Aromatic primary amines cannot be prepared due to double bond character between carbon and Cl. That cannot be displaced easily. Therefore option D. Next. In carbyl amine test for primary amines, the resulting foul-smelling product is, if we take CH3NH2 primary amine, which is methylamine, carbyl amine test, this is heated with CHCl3 chloroform and alcoholic KOH. It will form isocyanide, which is small foul smelling. So therefore option A. Foul smell is due to formation of isocyanide. This is nothing but carbyl amine test for primary amines, whether it may be aliphatic or aromatic. Next. Here complete this reaction. A, B, C. You have to identify A, B, C. So first it is given CH3, CH2Cl, ethyl chloride with KCN, potassium cyanide, alcoholic solution of KCN. It gives CH3, CH2, Cn, nucleophilic substitution. Next, say this is compound A, which on reduction, LiLH reduction means dissociate like this, break two bonds and H2 and H2. So this gives CH3, CH2, CH2, NH2, which is primary amine, and that is B. This is cyanide. Next, which on reaction with HNO2. with HNO2 aliphatic primary amines. This aliphatic, that means open chain, gives, remove here NH2 and place OH. That means like this, CH3, CH2, CH2, OH, alcohol, which is primary alcohol. This is C. Next, check the options. First compound is cyanide. Cyanide on reduction gives primary amine, aliphatic primary amine, that with HNO2 gives primary alcohol. So check option A is CH3, CH2, CN. Next CH3, CH2, CH2, NH2, CH3, CH2, CH2, OH. So option A. So this is the end of the chapter. In next video, I will explain one more topic. All the best and thank you.